Hi everyone, thank you very much for coming. I know it's hard to compete in a big hall. So today we're going to be talking about a company called KONE, who is probably they're probably one of the world's biggest companies you've never heard of, and you've used their products. So KONE are based out of Finland, and what they do is they make escalators and lifts. In America, that's elevators and escalators. Now, they are all about moving people around the world. And in any one day, they move about 2 billion people. So that's 2 billion people in an elevator, an escalator. They use automated doors. And they came to PwC with some very specific business challenges. So what they wanted to do was look at cost. They wanted to lower cost, no surprises there, pretty much everybody does. And they wanted to lower costs for their bottom line, but they also wanted to pass that saving on to their customers and clients, so that they could get a better price point for the new innovations that they have. The other thing they wanted to do was look at their customer insights. Why is that important? So what they wanted to do was understand how the products were being used in the field, what they could learn from it, and what they could improve, and what they could innovate based on how they were being used. But the other really important part of that is because this is a very technology and mechanical product, is what they needed to be able to do was see where it was going wrong and how they could support when it was going wrong. So that insight into preemptive maintenance, how long support takes, the impact of products being down was all very important. So they came to PwC, and PwC worked very similarly to AWS. So you're all familiar with AWS, the working backwards. PwC do exactly that. They start with the problem, they start with the ambition, and they work backwards. So what we did was we worked with KONE on a solution. Now, I'm not qualified to talk about that solution, which is why Ben is here, and I'm going to let him introduce himself and talk to you about what we did to help KONE with these problems.
Thanks, Nick. So hi everyone, Ben Lingwood. I run the cloud and data engineering part of PwC. So as Nick said, KONE, you now can't unsee that brand. So next time you're on I think that the travelators down on the strip, I think I noticed were KONE. You'll see them in lifts, you'll see the vans now on the freeway. It was an invisible brand to me before I started working with them, and now they're everywhere. So you will tune into the brand. Now, turns out when you move about 1/5 of the world's population every single day, and that generates a bit of data, right? And you look at what KONE had as a strategy for their company, is to become a data-driven organization. It all sits with the organization, whether you're making products, whether you're maintaining products, whether people are using them, it all generates data. Okay, so data is core to the currency of how they are running their business now and how they plan to move their business in the future. Obviously with a lot of the innovations we're seeing coming out over the last couple of days. So they're going through a journey, as you can see, from starting on the data journey right the way through to moving into more predictive areas now. Think about the anatomy of a lift, something I never thought about before anyway. Whenever somebody gets onto a lift, it measures how many people got on. Which floor did you go to? What time of day was that? What month was that? Is it a festive period? Is there a sporting match on? These are all the sorts of information that go into the insights as to how people use their products. And as Nick mentioned, helps them with R&D, how to improve the solutions, how to build better products, and then also predictive maintenance. Huge part of the business is maintaining these lifts. And if you can reduce the amount of call-outs, you can detect when there are parts going wrong, so a large part with predictive analytics looking at whether that's harmonic sensors, temperature sensors, movement sensors, bearing sensors on the products themselves, being able to predict from harmonics or an anomaly when that starts to go wrong, and getting someone out earlier means you guys aren't queuing at the lift for 3 hours trying to get out of the hotel to get here in the morning. So, we're all thankful for that technology, right? This is a large part of the journey they've been on, but it doesn't just stop with the products. Also look at their back office. They're running large finance systems, very complex supply chain solutions as well. It's important as well that movement of data from suppliers, and you've got to remember this is a global brand, whether that lift is in China or in America or in Asia or wherever it is in the world, that the right part is in the right place at the right time. That's something else that comes from the predictive element. So huge part of the journey that they've been through, and we've been working with them now for a couple of years on what we call the data movement layer. I'm not going to give any prizes for guessing what that does, but effectively it's the movement of data around the organization globally. Moving data, as you all know, cloud is fantastic. but it can also be really expensive. It can also be really complicated and complex when you're moving large-scale data around an organization this size. So, we've only got a few slides, by the way. I thought it'd be good to more have a conversation with you than throw loads of slides at you. Wanted to start with one of the particular use cases that they had, which is how to move data around the organization. And you heard me talk about the predictive maintenance side. They've got a program called Connected Devices. And that is, as it sounds, we're using generative AI, we're using language models, we're using IoT sensor data to start learning patterns to find out when a product is starting to break or starting to fail, when to order that part, and when to get that in. One of those particular areas that I wanted to double click on, the one on the screen here, was the back office. So this is an ERP solution. This is SAP actually in the background. And you can imagine an organization at this global scale, moving into large SAP finance templates, generates an awful lot of interfaces. As it turns out, just to run their SAP finance system is 220 interfaces of different types, firing numerous types a day. Historically, that was done with the third-party integration software. Expensive. If you're familiar with large integration software, they're typically charged on number of messages, amount of throughput, number of agents. You're all familiar with egress and ingress charges as that comes in out of cloud platforms. That can get pretty expensive pretty quickly. If you're firing millions or even billions of messages a day, when you add in the IoT data, that becomes astronomically expensive. So the conversation we had with them, the architecture that we sat down and worked with them, was to bring that back into cloud native and make that something scalable that they could use going forward. So just to describe the scenario you're seeing on the screen here, of those 220 interfaces, from a bit of analysis it worked out there's only actually 4 patterns to drive all those interfaces. So actually when you click through, a lot of repetition, not a huge amount of complication in the different types of way that they're sending messages. So we started this, as Nick mentioned earlier, with a discovery. So rather than being traditional consultants and throwing PowerPoints at each other till we were blue in the face, we went, right, 3 weeks, bit of discovery funding, thanks for that. Sat in a room and we actually prototyped this out and we had it working in 6 days. So it just goes to show you, Nick and Amazon principle, fail fast, give it a go, pizza box teams, get in there and give it a go, really paid off in this element, in that doing the design, validating that, and that was a full end-to-end test, actually validated that this was possible, it was a new idea. So of those 4 patterns, you can see there's 4 on the screen here. So we had data coming out from SAP, if you're familiar with that, iDocs, ABAP code, data coming out, into SAP's BTP suite, business transformation product, that's BTPIS for the integration suite. And then from there, we picked it up from the DML team rather than it going into a third-party middleware application. So 3 patterns here, 4 patterns I should say. Pattern 1, by the way, in case you're wondering why it started at 2, is because that was SAP to SAP, that's native. So we started at 2, just in case anyone thought that was a mistake, it wasn't. So pattern 2. Reasonably straightforward, taking the data out from SAP Integration Suite in its native format, by the way, that's an RFC call. We can integrate that RFC call straight into Amazon Gateway, API Gateway. So we're using actually the native API Gateway to ingress that as an RFC call, so a direct function call in. And we use Lambda functions to then change the payload. So as you can imagine with a company this complicated, the number of satellite receivers is huge. So while there's only 220 interfaces in this scenario, there are many, many, many multiples of that as a recipient system. So we can do one-to-many and do message splitting as part of this. So the API gateway was used to ingress that as a call. Lambda functions, we're using Python steps inside Lambda to then split that out and change that into the right format. So step functions within that and push it out to the recipient satellite system. That's bidirectional, by the way. So if you've got a particular advanced supply chain, as some of them do, it means that reverse call can happen. The client or the customer can make a reverse call back to the API gateway and come and fetch the data. So that was synchronous. Push and pull, get it and fetch it. That was pattern 1. The second pattern, asynchronous. So this is when it starts getting a little bit interesting. We're using Kafka quite heavily here. So we're using subscription topics within Kafka. As the data's coming out, we can set receiver and then target subscription topics within Kafka, and we're using Event Bridge again to drive that message out into the satellite system. Now this is asynchronous because obviously it's a subscriber topic, and again, if you've got an advanced supply chain user, they can subscribe to that Kafka topic. So if you're familiar with that, subscribing into that, putting the data you want, and again, we're using Lambda to split the functions down to get that into the right format. Typically, that was out into a Java payload, sometimes an XML payload. Some of them want to do it natively with APIs. But citizen developer means that we can push it out to the client and say, here's your subscriber topics, off you go. So that was quite liberating rather than being too prescriptive. Down to the fourth pattern. Now this was an interesting one, back to the point I was making earlier about the interface payloads being used for IoT and ML and learning projects, especially for the supply chain. We sent this to a thing called KDP, KONE Data Platform. So this is effectively their data lake. This is a vast, great S3 Glacier layered data lake where a lot of the data that comes from telemetry from the lifts, from supplier information is stored. And as we all know, if you're building AI models, and we'll sort of come on to some of the bedrock topics that they're doing afterwards, that is being used as a data source for a lot of the RAG models being developed at the moment. Right, so valuable information. That model meant that we captured the payload information and stored it into S3. And because it's now stored into S3, you can start doing predictive queries. So KONE can come in to go, right, okay, let's say there's a pandemic or a football match or if people coming back into the office more, what does that mean? So if you look at our office, it's packed on a Thursday, it's reasonably quiet on a Monday or a Friday. You can start taking a look and looking at the payload information about what is going on and start writing your queries. So this was a very inexpensive way to start capturing payload and interface information and pushing it back down into S3 for queries. And again, that's using Databricks and Glue on top of an S3 repository. Fourth pattern. And then the last one is what we called a DML data host. So this is for high velocity lookup. So if you're in a scenario, let's say it's a sensor package where the third party or the organization is making very high velocity, multiple, thousands of queries to that data store. Again, this was done for cost as well as for speed. That can get A, expensive if you're using quite a complex architecture, and B, can be a little bit laggy, right? So if you're having to call, let's say, back into the ERP to get, let's say, it's supply chain information or finance information, by caching and storing that data, in this case we use DynamoDB, into a persistent store, so interface data into the persistent stores, means we can do high velocity lookups into that without really breaking a sweat. Okay, so 5 patterns, so 4 on the screen here, that did this all within native Amazon services. And this replaced 7 figures worth of middleware, the maintenance that goes with that, the support organizations needed with that, the licensing that's needed with that, and yeah, you still need the infrastructure to run it. So a good story of how you can use native services to replace typically what you've got to pay expensive middleware solutions to do. So I hope that's been food for thought. And rather than me or Nick talking at you, it's always good to hear from the voice of the customer. So hopefully if I press this button, Lulu Zhang, who heads up Head of Operations for KONE globally, should appear on the screen.
As a global leader in elevator and escalator, KONE moves 2 billion people every day. To manage this immense data flow, we've implemented a scalable, cost-effective data movement layer, DML, powered by the native AWS solutions. This platform supports fit-for-purpose, frugal development, ensuring competitiveness and efficiency in managing data across the organization. Our DML is essential to KONE's broader data foundation strategy, supports everything from predictive maintenance models and AI engineering to financial analysis and operational reporting, ensuring data drives the innovation and decision-making across the business. In collaboration with the PwC, we've improved our reusable integration architecture. For example, over 200 external SAP interfaces could run on just a few reusable AWS native data integration patterns, demonstrating the power of simplification. Ultimately, this aligns with our vision of becoming a data-driven company, driving operational efficiency and leveraging cloud innovation to transform the way we work.
Okay, so as you've seen, it's really impacted the customer and their journey. They're making better decisions about when to maintain, how to maintain. Is it predictive? Is it ahead of schedule? Or do they wait for it to break, depending on the data? But actually, the other thing it's done is help them look at that innovation cycle. So again, we're working with them and their R&D team to go through the projects that they have in pipeline and help them prioritize based on need. And that's based on data rather than what we think we need. And that's the collaboration with PwC and AWS. So thank you very much for your time. And just a little bit of extra time. Does anybody have any questions?